Hey class. Alright, last video I believe we did a little introduction into videos here, and we're gonna continue on. Uh, Talk a little bit more about different variables, different types, how they work together, and kind of how we use them. So I'll just make a new project and go through it real quick. 05 and whatever the day's date happens to be, you just put it in. More variables. So the purpose of variable is to hold some information for us so we can use it for later. Now, this can be math, it can be names, it can be, whatever we want. Yep. So, let's talk about the math portion of this first. Let's say I have two numbers and I want to do a little math with them. You know. Now, for naming, I can't have a space. It has to be one whole word. I can't lead with a number or a weird funky symbol. Uh, let's just say 10. And int number 2 equals 10. Now if I do a little math, I can say, int total equals, I could say 10 times 10, or I can just say number 1 times number 2. Now just so you know, math-wise, you have your addition, you have your subtraction, you have your division, and then you have your multiplication, which is the star. Uh, Other things that can be used for math would be this, which is modulus. You've also got this, which is called the caret symbol, which is raised to power. Now with this, I can simply print a little message, and I can just say, the total is plus total, tax it onto the end of this string. If I don't put the plus there, it won't be incredibly happy. If I put the total in quotes, then what I'm going to end up getting is, well, that whole word instead of the actual variable. So this part is the string. I want to add a variable to the end, and you'll see that 10 times 10 is 100. Now if we look at this another way, the total is, I could do the math here. Now I do need to have the parentheses around it, because if I don't, what you're going to end up getting is this. Oh well, never mind, it worked this time. But if I have pluses, let's see, I guess it knows that multiplication isn't an add symbol. It puts 10 and 10 together. But even still, it's far better to have the parentheses around it just to make sure, especially if you're doing more than just one operation. For example, number 1 times number 2 plus this minus that. If you have more stuff, you absolutely have to have parentheses, especially if addition's involved. So we've got the total, which is factored here. Whenever you're doing a program, generally, if you've got a bunch of numbers and you want to figure out a total or some math of a couple of variables, you'll make a variable and do it this way. I would honestly tell you to do it this way instead of this. And the reason for that is it really depends on what you're doing for the most part. But if there's some program I have to do where I have to figure out a lot of little mathy things, it's better to have a variable where I just have to print that one variable than to try and do the math inside the print statement like this. Two reasons. Reason one, well, I did my math here and I just have to print that one variable. It's easier. It's much easier to do some long complicated math statement here and put it into this little variable here, and then I just have to plus that word, than to try to do it inside this print statement where you could have any number of problems. Reason two, uh, if I need to use this again, I can just come down here and print total, or multiply total by 10, or do whatever it is I need to do. If I do it inside the print statement, basically the total only happens inside that print statement. If I need to do it again, I'll have to copy and paste this complex, however complex it is, set of numbers again and do it again. Uh, One of the early programs does require a little bit of adding and multiplication. Uh, let's say I have three totals and I have to add all three of them together. So I have three sets of numbers like this: total 1, total 2, total 3. Uh, and then I just do all the adding here. It's just much easier just to do it in one of these little variable statements than it is to do it in a print. Because I accidentally don't put a parentheses where it needs to go, this whole thing screws up. All right, well that is just simple integers, and doubles work exactly the same way. So double num1 equals 3.14, double num2. And I can't have the same thing twice. It's going to tell me that that number's already defined. Now I could, of course, capitalize it. And that is perfectly acceptable, actually, because capital letter is different than uppercase letter. But that's super confusing, and I honestly would tell you not to do that either. Just name everything different. Now, if we're in a program and you have to figure out what the tax is, what the monthly payment is, or whatever it happens to be, don't call everything num1, num2, num3, num4, num5, num6, num7. Name the variables whatever they are. Uh, Too often I have students who, we look at these examples here and I'm simplifying them. But when they do it, they open this example and they just copy. Well, this is number 1, this is number 2, this total is going to be number 3, this total is going to be number 4. Name it whatever it is. It makes things a lot easier. If this is like, this is pi, and this is like my payment or something, then name it that. Like that. Don't just call them num1, num2, num3, num4, because that is, especially as a program gets bigger, really, really confusing. A lot of people have issues with that. So, all right, let's continue. Uh, just want to make sure everything's all right. All right, so I've got these two, and it's the same setup, basically. I can make a double total 2, for example, equals pi times payment. And I can name these pretty much whatever I want, so you should use those names there. So this total is, I'll just call it the double total, is plus total 2. And you'll see 46.6918. It does the math right there. Now, anytime we're doing numbers, you have to decide whether you want a double or whether you want an int. If it's money, it's a double. That's just the easiest way to represent it. You could use a float, as we discussed previously, but honestly, double, it doesn't really make a difference at this level. If we're talking about, I have 5 chickens, then that would usually be an int. Now you can multiply an int times a double. And what you end up getting, now a double times a double is a double. An int times an int is an int. So the question here would be, what do you think an int times a double is? Well, I'm just going to do it inside the print statement. Int times double. And I'm going to say number 1 times pi. And I'm just going to go ahead and put parentheses in there because it's just better habit, better way to do it. There should be one more parentheses here. So what do you think that's going to end up being? Well, here's the hint. Int is a smaller primitive. A double's a larger. Anytime you multiply a smaller times a larger, you get the larger. So in this case, you'll notice I get this 331.40000 blah, da, 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 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, I think 16. I think that's what I said, 16. Floats about 8 or so decimal places. But it'll always end up giving you the bigger one. Equals double, like so. Now if we're doing strings, for example, or characters, single apostrophe, let's go with F. 2 P. And I can't just put a P here. And the reason for that is, well, if you check, cannot find symbol, it thinks it's a variable. I could name a variable P. But this is a character, which means a single apostrophe. Now, if I make a string, capital S, not lowercase s, for reasons we talked about before, word is, now if I go letter 1 plus letter 2, notice that it complains. Incompatible types. Int cannot be converted to string. That's interesting. Because these are characters, right? Now, technically, if I were to actually, well, let me just show it to you real quick. If I said int n equals letter 1, what do you think happens? Notice there's no errors. Now, if I print this, y plus n, and I'm just going to comment this out real quick and we'll get to this in a second. But take a look. It's perfectly fine putting the p, or in this case, I think it's the f, into an integer. And if we run it, we end up getting 102. Now, what you end up getting actually is the ASCII table. Let me just show you what that is. And this is actually somewhat useful for some things, which we'll talk about another time. But I said 102, right? Check out what 102 is over here. In my ASCII table, 102 is F. That's the location, basically. It's F. So if I were to increase that to 103, I would get G, right? So the reason I can plug a character into an integer like this is simply because technically, as far as program is concerned, it's just going to point it to that ASCII table location. So if I were to say, for example, letter 1 equals letter 1 plus 1, that's adding 1 to it. Notice it complains a little bit here. Well, I could do it a little bit cheaper. Let me just do plus plus. It'll be fine with that. What the plus plus does, and you will learn about that as we push further on, it's going to add 1 to that variable. So what do you think would print in that letter? It's now printing 103. Now, what if I just printed the letter? And I got this. Let's just print the actual character instead. I come down, what in? This will be letter 1. Now, and you get out the way. There we go. It's G now. It was F. I did the plus plus, which adds 1 to it. And this can be used for ints, mostly. But you could also use it for characters, because it kind of treats them as an int. That doesn't really bother anyone for what we're doing now. There are a lot of cool things we could do because of that, but we'll worry about that later. So I can actually plug a letter into an int because it is an int. That's why that works. But again, we're not going to be that concerned about it right now. Now, here's the problem here. And this is why it gives this error. Incompatible types, int can't be converted to string. Well, it's a character, or in this case, an int, and I can't say, word is, 103 plus 108 or whatever. But what I can do is this, equals, quote, quote, plus. Now, check it out. Oh, well, I guess I got to print it, but it doesn't have that error anymore. We do a little print. I'll print word. And what you get is GP. It added those things together. So this works because we got a string, and basically just like with our print statement up here, we're just tacking these on to the end. So if I put like 1,000, you'd get 1,000 GP in this case. Hooray. So basically it just tacks it on and puts it all as one string. Uh, so I can do it as long as I have a string in front of it, basically, is what that means. Now, for the most part, most of our strings will just store names or, you know, things like that. And you won't really have to add anything to it or take anything away from it. But this is how you would do it if you wanted to do it that way. Now we've covered ints, doubles, characters, uh, strings. The last really one is Boolean, but there's really not much we can do with that. It's either true or false, and it's typically used with if statements, which we haven't gotten to yet. We will soon. Uh, you can use it to trigger certain events, let's say in a game or in a program. If they click a certain button, if they click exit, that is true, then close the program, close the game. If you said a particular thing in a dialogue choice in a video game or something, then hey, that Boolean is set to true. And then whatever event is going to happen because you said yes, happens. If you said no, maybe another event gets triggered. That's what those are typically used for. A game will have hundreds, maybe thousands, of little booleans that just are flags that are triggered, true or false, if you do certain things. Same is true for any program. If you check a checkbox, if you know, the data is correct, or you put this in, or you didn't do this, it's used for all kinds of things. This is just a quick rundown of how we would use uh, variables. A little bit of adding, a little bit of math, and we can multiply, subtract, whatever we want with this. With characters, we can put a little character in there if we need to. It's not often you really have to work with a single character, but you can. We can increase that character and move to the next value, which is where that ASCII table comes in play. Which, again, you don't have to worry about that much. I'm not going to ask you to memorize the ASCII table or anything. But it is useful to know what it is and why it works that way. And again, how we would deal with strings if we were, you know, doing it. We wanted to print this one string. If I want to put my name in there, maybe tack on the last name, I could take this string and even add another string. I could have string word 1, and then add them together just like I did with this. And the way it works is it concatenates them, meaning it'll take the first string and just tack on the other string to the end. Kind of like what happens here. All right, well, if you have any questions or comments, just leave a little message down below or anything. If you have any problems, just let me know.